All right, so now we're into areas of parallelograms, and it's pretty simple because if we have a square or rectangle, you probably know the area is length times width or base times height, and that's exactly what it is for parallelograms, with the exception of a rhombus, which we'll talk about in another lesson. So it's important to identify the base, and there can be two bases, right? So it can be any of the sides times the height, and the height is the key. And so what we're trying to do is look for the 90-degree angle. So the height can also be called an altitude. And again, look for the 90-degree angle. Sometimes it's inside the parallelogram, or sometimes it could be outside. But that height is going to be perpendicular to its corresponding base. So the height will be perpendicular to a corresponding base, right? And most times one is going to be easier to work with than the other in terms of what sides to choose from. So if we look down here, there's three numbers, and we have to pick two of them because we want the base and the height. And we know the height has the 90-degree angle. That means the base has to be 12. So our area would be 12 times 8. Over here we look, there's three numbers. We want the height, which in this case would be 5, times 10. So the height is perpendicular to that particular side. So that would be 5 times 10 for your area. Over here, the height is 5.6, and it corresponds with 15.8. Right? Now, in each of these examples, they give you a number we didn't use, and that's called a slant height. And in a previous lesson, we talked about Pythagorean theorem, and sometimes we may need that slant height to find the height of a particular shape, a parallelogram, a trapezoid, or whatever it might be. So sometimes the numbers there we don't need for a particular problem, but we might need it in a different problem. All right. So in this example here, now we're graphing. So we plot our coordinates, and we see that these are parallel, so we have a parallelogram. And so what we need is the height. So in this case, we don't necessarily see the 90-degree angle, but we can figure it out by counting vertically and horizontally. So the base is 4, and the height is 5, and so we multiply 4 times 5, and that would give us an area of 20. All right, here's another one. We plot the coordinates, and then we find out this. In this case, this would be considered the height because it's going to be easier to determine perpendicularly what is going on. And then the sides are going to be the bases, technically. And you can always consider rotating your paper to make it more visually appealing to you. So this distance here is 9, and then this distance here is 12. You could use the diagonal distance, but again, if we use this as a base, the height has to be perpendicular, and then that just becomes more complicated. We can figure it out using distance formula, but this way is much more simpler. All right, then we have these problems here where they give you the side lengths, and then they want you to say, okay, there's a corresponding height. So in this case, this base has a corresponding height, and remember, again, we said that it has to be perpendicular, and so that one would be 9. So 15 times 9 would give you the area. But what they actually want you to do is find the height that goes with 18. And so because we know the area is 15 times 9, whatever 18 times its height is, it's going to be the same value. So we set up this equation like so. And so you get this number, and then we divide it both sides by 18, and you would get 7.5. So the key in this problem is that word corresponds. So corresponds means it matches or goes with. Okay, so let's take another look at an example. So in this case here, we have two sides, 9 and 18, right? And the 9 side has a height of 10, and the 18 side, we don't know. And so in this example, we would divide both sides by 18 to get an x value of 5.